Okay, Oak Rovers, this is going to be a video to help you factor more complicated difference of squared problems. Hopefully you've already watched my video on how to factor difference of squares. This video is going to look at problems that are just a little bit more complicated. Now let's look at the very first problem, which happens to be 36C in section 8.1.4 in your Algebra Connections book. And that problem is 2x squared minus 50. So if I look at this problem, this is kind of like an example of how to factor completely and how to do the con exercise of factoring quadratics too. If I look at this problem, I can factor this problem before I put it into my generic rectangle and diamond problem. So let's go ahead and do that. And in this problem, I can factor a 2 out because they both have a factor of 2. I mean 2 and 50 both have a factor of 2. Now I put my x squared down there, my negative 25 up here. I'm going to get a product of negative 25x squared, and I'm going to get a sum of 0. I know that two numbers that give a negative product, they have to have a negative 1 and a positive 1, but the sum is going to be 0, so they have to be opposites of each other. So I have 5x and negative 5x. When I put them into my generic rectangle, I can factor an x out of my bottom row, and if this dimension's x over here, then this dimension has to be x to get the area of x squared. And then after I do that, if this is x, then that length has to be 5. If this is x, this length has to be negative 5. So now when I write this as a product, because it's written as a sum up there, I'm going to do the same thing I did in my factoring quadratics 2 problems. I need to make sure that I have that 2 in there, and then I'm going to multiply it times x minus 5 and x plus 5. So it should look something like this. 2x squared minus 50 is equal to 2 times x plus 5 times x minus 5. Now let's look at this next one. I have 3x squared minus 48. It's almost identical to this one up here, except I can factor a 3 out of 3 and 48. And when I do that, voila, I get a difference of squares inside the parentheses. So it's 3 times x squared minus 16. So I can put my x squared term down here, my negative 16 up here. These two have to have a sum of 0, so I put the 0 down there. These two have to have a product of negative 16x squared, so I put that up there. I'm going through it a little bit faster now because you've seen it quite a few times. Hopefully you've done these quite a few times also. And then I know that positive 4x and negative 4x give me a product of negative 16x squared, but they give a sum of 0. So those are the numbers that go into these boxes. I can factor an x out of my bottom row, so that becomes x. If this is x and my area is x squared, then that's going to become x. If this length is x and my area is negative 4x, that's negative 4. And if this is x and my area is 4x, this length will be positive 4. Now, again, when I write this completely, when I write this as a completely factored difference of squares, I need to make sure that I have that 3 there. So it's 3 times x plus 4 times x minus 4. And I have that written right here. 3x squared minus 48 is equal to 3 times x plus 4 times x minus 4. Now the big thing that you have to remember on this problem is I need to make sure that I put that 3 into the equation.